Hello, and welcome to our case presentation for today. We have our two hosts, Dr. Michelle Daniluk from the University of Florida, from the Department of Food Microbiology and Safety. And we also have with us Dr. Lawrence Goodrich. He's from the Leon family. He's a Leon family professor in food safety from the University of Guelph. Welcome, Dr. Goodrich.
Thank you.
All right, so Larry, let's go ahead and get started. We're going to talk a little bit about an outbreak that happened back before you were at the University of Guelph, while you were at Colorado State University, that was linked to whole cantaloupe. And I want to start by asking you a little bit of, can you tell us about cantaloupe production in Colorado?
Yes, thanks, Michelle. So in Colorado, cantaloupe production happens in the Arkansas Valley around a town called Rocky Ford. And this is a very interesting town. It's very small. It's only 1.7 square miles. And it's become famous nationally and internationally for its melon production. So that includes cantaloupes, but also watermelons. And so since 1895, Rocky Ford has been producing very high quality cantaloupes. They're famous because of their taste. They're very sweet, which has to do with the temperature variations between day and night in the Arkansas Valley.
So Larry, are they a really seasonal fruit, or are they on the market for a fairly long amount of time?
They are seasonal. And so every year there's a period, only a period of time when they're available. They are shipped nationally.
All right. So in 2011, a Listeria outbreak happened that was linked back to that Rocky Ford variety. You were there then. Can you talk us through a little bit about what happened in that outbreak and why, sort of in the fresh produce world, it's such an important outbreak for us to talk about?
Yes. So in 2007, the Colorado Department of Public Health became aware of a cluster of Listeria monocytogenes cases. It was puzzling at first because a food vehicle could not be identified, and cantaloupes were not thought of initially because for several reasons. Number one, while people did report eating cantaloupes, whole cantaloupes, there had not been a Listeria monocytogenes outbreak linked to whole cantaloupes. And there were other food vehicles that seemed to overlap. So it took a little bit of time before from epidemiological investigations, reports seem to center on cantaloupes, so not just cantaloupes, but the Rocky Ford cantaloupes. And so subsequent investigations confirmed that that was the source of the food source of the infection. And so this was a large outbreak. 20 people from 28 states became ill, and it ultimately caused illness in 147 people, with the majority of them, 143, hospitalized and 33 deaths. And one thing about Listeria monocytogenes is that in a Listeria monocytogenes outbreak, approximately 20 to 40% of the people who are infected will die typically. And so we see, here that 33 deaths out of 147 is certainly within that range. And the case, sorry, go ahead.
No, go ahead.
I was just going to say, it was also a fairly long outbreak with cases from July to October in 2011, excuse me, which does encompass the Rocky Ford cantaloupe growing season.
So yeah, I want to ask you a little bit about that, because I think you said some really interesting things there. The first is about cantaloupe not initially being or taking a long time to be linked to the outbreak. And I think that for Listeria, right, we didn't historically look at foods like whole produce. Our focus was very much on luncheon meats and soft cheeses and sort of a lot of those ready to eat refrigerated products, maybe including fresh cut, but certainly not whole melon. So in your experience, that really lengthened the amount of time for them to get back to cantaloupe in that outbreak?
Yes, it did. Because as you said, the first thing that was looked at were these ready to eat deli style meats. The other thing that really delayed, at least initially delayed, investigations of the cantaloupe is the fact that in a Listeria monocytogenes outbreak, it can take up to 70 days after eating the contaminated food before symptoms show up. And so it can be very difficult to for people to remember what they ate. And so in any foodborne outbreak investigation, one of the first things that happens is that the sick people are interviewed and asked, what they ate. And it's not an open-ended question. There could be some suggestions because of the fact that it's hard for people to remember. So initially, whole cantaloupes were not, that was not asked of people because, as we've said, that was not understood to be a vehicle from which Listeria monocytogenes could infect people. So all these things delayed initially the investigation of whole cantaloupe.
So you also mentioned, and I think this is important, we talked about on the previous slide, we talked about this Rocky Ford cantaloupe being a very seasonal product, that there certainly was a season for it every year, but then we look at cases from July to October. So you mentioned Listeria could take up to 70 days to really cause symptoms. Can you talk a little bit more about why it is like that?
So Listeria monocytogenes is a bacteria that is viewed as being able to grow in many different environments. Certainly in the agricultural environment, in soil, it's been found in water. It's known as a zoonotic bacteria, which means that it is found in animals, such as ruminants, but other animals as well. And then zoonotic means that can be transferred from animals to humans, which typically occurs through the environment, as was in this case. And so, so because it's found everywhere, it is a bacteria that it doesn't cause a lot of foodborne illness relative to other bacterial pathogens like E. coli, 0157, or Salmonella, but when it does cause outbreaks, it has a much higher death rate than those other bacteria. And so when people become infected with this bacteria, it actually gets into our gastrointestinal tract, and then it invades our cells, the cells that line the gastrointestinal tract, and it actually grows inside of those cells. And it can take a long time for that to happen. So this is why it can take up to 70 days. It doesn't take 70 days for everybody, but it can take up to 70 days for people to become sick. And another thing is that's really important to know about this particular bacteria, Listeria monocytogenes, is the fact that it really causes illness in certain high-risk populations, those being pregnant women, and the elderly, and newborn babies. And with respect to pregnant women, it can actually cause abortion as well. So this is a very serious cause of foodborne illness.
Yeah, a little bit different than some of the other ones we talk about in our other case studies. So you mentioned that it's found everywhere in the environment. Can you talk a little bit about some of the investigations that went on during this cantaloupe outbreak, where they were looking for Listeria and the source of it and the source of the contamination?
Yeah, so once it appeared that cantaloupe was a cause, as determined by the fact that people who had been interviewed and re-interviewed talked about eating cantaloupe. Um, and I just want to focus on this for a little bit, because it even became complicated then, because while the outbreak was ultimately linked to whole cantaloupe, um, once cantaloupe became the suspected food vehicle, a lot of people reported buying whole cantaloupes, but a lot of people also reported eating cut cantaloupe, because perhaps they went to a restaurant that had bought the whole cantaloupe and then cut it up and so forth. So cut cantaloupe, cut melons, of course, have previously been understood to be a source of foodborne investigation. So that complicated the investigation somewhat. But once it really seemed that cantaloupes, and in particular whole cantaloupes, were the cause, then the investigation turned to the growers, and in an investigation, the idea is to try to find the actual source of the contamination. So this meant that visits were made to farmers who were growing cantaloupe. A number of visits were made to farms, and sampling in the fields were conducted, but as well as sampling in processing facilities, post-harvest processing facilities, and vehicles that would be used to transport the harvested cantaloupes to those facilities, which in some cases were on farm. No Listeria monocytosis was found in the field. So by that, what I mean is the actual fields where the cantaloupes were grown and subsequently harvested were sampled. The soil was sampled, um, and no actual Listeria was found there. Water used as an irrigation source was sampled. No Listeria monocytosis was found there. However,
yeah, so that's a little bit, I mean, you just said previously that Listeria can be found everywhere, right? It's found in soil, it's found in decaying plant matter, it's found in all these animals. So was that the result of not finding anything in the field surprising?
So that's a great question. I mean, Listeria can be found everywhere, but that doesn't mean that if that you're when I say it can be found everywhere, it has been found in these different places, but it doesn't mean that every time you sample you're going to find it. So but because it can be found in these places, soil, water, and animals, including wild animals, then it's important for produce growers to understand that that's a potential risk for contamination of their crop, and to take appropriate measures to try to reduce that risk. So the sampling was done. The other thing I will say about this particular year, 2011, was a very, very dry year. And so there was very little rainfall that year. So that could also have potentially decreased the potential for the Listeria to be found in the environment that year. So so a number of farms were sampled, and several processing facilities were sampled in the Rocky Ford area. And one particular farm was highlighted because Listeria monocytosis was found in a processing facility on food contact surfaces on the packing line. And so subsequent investigation of the packing line found that the line was actually repurposed for cantaloupe. It was originally used for potato processing, and it was repurposed for cantaloupe. And so because it was used for potato processing, of course, potatoes have a lot of soil on them. And as we've said, Listeria monocytogenes can be found in soil. This line was also shown to be very difficult to clean. It was never considered. It was never built for cantaloupe. So, and potatoes are a food that are not consumed raw. So the risk of potato contamination with Listeria monocytogenes and people getting sick from that is a lot less than it would be for cantaloupe, because people eat this eat cantaloupes raw. So the line was repurposed, and subsequent investigations found that the Listeria was present in several places on the line, on the food contact surfaces, and then also that cantaloupe that was in cold storage, it was a cold room, also tested positive for Listeria monocytogenes. So this really provided strong evidence that this was the source of the contamination. And definitive evidence was determined because in an outbreak investigation, when people become sick with the bacteria, in this case, Listeria monocytogenes, and they go to the hospital, stool cultures are taken and the bacteria is grown from those stool cultures. And then the subsequent investigations aim to link that to the food. So in this case, once the cantaloupe was shown to be the cause, cantaloupes were recalled from grocery stores. They were tested for Listeria monocytogenes. Listeria monocytogenes was found. And then at this packing line, these same Listeria monocytogenes bacterial isolates were also obtained. So now we have isolates from the packing line, from the cantaloupe, and from people. And to definitively link those isolates, a method called genomic testing is done, where the DNA of the bacteria from each site is compared. And if it is identical or very, very similar, then we can conclude that this was the source, and that was what was found in this case.
It's like CSI food safety here, right?
Yes,
Where
exactly.
they were able to sort of look at the whole system and find the same DNA fingerprint in the patients, on the cantaloupe, and on the packing line. Is that common in produce safety outbreaks, or is that sort of a unique thing that can happen?
It's actually unique because in many cases, in terms of fresh produce, the shelf life is so short that by the time an outbreak is known, and that's one thing we should talk about. Typically, in order for an outbreak to be discovered, it really relies on the sick individuals to go and seek help. So most people, if you think about having a foodborne illness, most people have had a foodborne illness. I have. I'm sure you have. I certainly did not go to the hospital.
No, as little as I can, I go to the hospital.
Exactly. So that means that the public health officials don't know anything about us. They don't know that we were sick. They don't know what we were sick with. They don't know what we ate. So because of that, it takes on average about 3 to 4 weeks after somebody eats a contaminated food before public health officials really know that there's an issue. And in this case, it may have taken even longer because, again, it can take up to 70 days for people to have symptoms. So by that time, if you're thinking about fresh produce, most, if not all of it, is gone. So it's hard. So there's nothing else to link to from a food standpoint to link to the actual people. And then it can often be hard also to find the bacteria in processing facilities, or if if it was because of irrigation water, for example, that contamination source may no longer be there. So with fresh produce outbreaks, it can be very hard to definitively link the outbreak to a specific cause. However, one can certainly develop a good idea of the cause. In this case, we were fortunate enough that we were able to recover the bacteria from both the food, the cantaloupe, and the packing line.
Perfect. Thanks. So I think this outbreak is interesting because it was a new one for us. So can you sort of review to the farmers that might be listening, what are some things that they need to learn from this outbreak? What are sort of the lessons learned in this outbreak?
So the first thing is to understand that Listeria monocytogenes is a bacteria that because it can be found in many places in the agricultural environment, it can contaminate food. And one thing we didn't talk about is it's very good at contaminating processing facilities, where it can survive in areas where there's water. So we talked, for example, about the Listeria monocytogenes being found in cantaloupe in the cold room, and it was thought that condensation in that cold room actually led to the spread of the Listeria onto other cantaloupe, which made the outbreak worse. So there should not be any standing water or all sources of water in a food processing, fresh produce processing facility should be eliminated, because this could lead to growth of Listeria. And then the second thing is sanitary design of equipment and sanitation, and cleaning are very critical. So in this particular outbreak, the processing line was not designed for cantaloupe. So it's important to understand that if equipment is being repurposed for a purpose that it was not originally designed, that must be done with very serious thought, and an understanding of how the new use could affect the potential for bacteria to be present. The equipment needs to be, of course, clean and sanitized properly and regularly. Environmental monitoring should also be conducted from time to time, and there are very simple ways that could be done to check whether equipment is being cleaned and sanitized properly. That will go a long way to decreasing the risk of contamination. And the third one, we touched on a little bit already, that changes in production and packing practices may alter food safety risks. So this is really about again, understanding if any changes are made to how produce is grown and harvested and packed. In this particular outbreak, this was the first year that they had introduced this new equipment. So, the question might be, well, why didn't we see this before? Well, that's because they had introduced this new equipment only that year. And so that is a perfect example of how a change in this case packing practices, without fully considering the food safety risks, led to a major outbreak of Listeria monocytogenes.
Yeah, thanks, Larry. I think those are some really important lessons for our growers who are listening today to learn. And for those of you listening, we do have short videos talking about things like sanitary design and environmental monitoring in our instructor-led webinar series. So I encourage you to take a look at that to learn more information there. So Larry, as we get close to wrapping up this, what are some of the things that the growers who are listening can do in their operations and from the learnings from this outbreak, so that they don't find themselves in a similar situation to what we saw for the folks the farmers that I think thought that they were doing everything right out in Colorado.
So there's several things that growers can do. The first thing is to understand that Listeria is a food safety hazard and that it can and has contaminated the whole fresh produce. The second thing is to include cleaning and sanitizing procedures in day-to-day operations and environmental monitoring. The third thing is when retrofitting or modifying equipment or even repairing equipment, consider food safety risks. Repairs can be made to equipment that subsequently make it harder to clean. So everything should be done from the point of view of thinking about where would contamination occur in this equipment and how easy is it to clean and sanitize. Consider field or dry packing melons. So this one's really important. As we've talked about water, whenever there's water, bacteria like water, not just Listeria, but other foodborne pathogens, Salmonella, E. coli, they like water, they need water to grow. So removing that water source, we've already talked about in the packing house, removing water sources or standing water and so forth. So the same can be done in the field. If melons are field packed and dry packed, then if there is any Listeria there, that would greatly reduce the risk of it growing to a high number and being spread to other melons. And that's important because we know that there's, for most people, for healthy people, that is those that don't have some underlying health condition, a large number of Listeria monocytosis cells are required to cause illness. So if you can reduce the even if it is there, if you can reduce or stop it from growing, that can also decrease the risk. And also finally, to remember, changing practices may alter food safety risk. So changing practices such as changing how one harvests and processes the melons may increase the food safety risk. And the other thing I'd like to say is that it's important that employees are constantly trained on all of this. There can be high turnover of employees, and so that could also be a changing practice where a new employee or employees come in, and if they aren't trained or made to understand the importance of food safety, that itself could lead to conditions in which an outbreak occurs.
So Larry, we've been talking about cantaloupe melons, but do you think that these lessons are transferable to watermelon or honeydew or other types of melons that somebody might be growing?
Yeah, absolutely. These all of these best practices are transferable to any whole melon, because any melon can potentially become contaminated with Listeria monocytosis or other foodborne pathogens.
And then we talked a lot, you talked a lot, I talked a lot about cleaning and sanitizing, but we also talked about limiting water in facilities. Are there ways to clean and sanitize that don't necessarily include using water?
Yes, there are ways to, so that is also something that we talked about dry packing of melons or field packing of melons. So similarly, in the packing house, there are methods to clean and sanitize that do not require water or require only a little water, much less use of water. So really the take home is that the use of water should be limited as much as possible, whether that's in the packing house or in the field. The other thing, one other thing to consider is the design of the packing facility. So in this particular outbreak, it was an open air facility. And so the source of the Listeria monocytogenes was never definitively found. So by that, what I mean is it was found on the equipment, but it was also found on a truck that had been used to transport the melons from the field to the facility. So it's unclear whether it came in on the melons or it came in on the truck. Again, it was a very hot, dry summer, so it was thought that perhaps dust could have blown in from the truck into the facility, and that's how it got in. So you know, those are some other things to consider. You know, if a truck is used or some type of vehicle is used to transport the produce to the facility, then it shouldn't be parked immediately adjacent to the packing facility, as was in this case. It should be moved. So these are all of the some really good best practices that should be employed.
Well, perfect, Larry. Ashley, do you have any further questions for Larry?
No, I don't have any other questions, but thank you so much, Larry, for this presentation. Learned a lot about this case study. If you have any other questions for Larry or for our other host, Dr. Michelle Danieluk, please feel free to email them at their respective emails. And thank you for tuning in today.